Welcome back to the Math Professors. We do videos that cover topics that are found in any college math class. Today I'm going to do some transformations. So if you like our content and you want to help us grow our channel, please consider liking, subscribing, and sharing. So, transformations. Let's talk about horizontal, vertical, and we're going to start out with rigid transformations. And what I mean by a rigid transformation means I'm just moving the graph like left and right and up and down. I'm not changing its shape. So if you think of like a video game, really the pixels on the video game are nothing more than technically like a function. It's a defined function. So, if you look left, you look right, the map is not really, manipulated. It's really just kind of shifted left and right. If you look up and down, you can see it do this. So this is technically how it can be done. So horizontal transformations are, well, you're going to manipulate the x values. The x is your horizontal axis. And then for the vertical axis, you're going to manipulate your y values. So the way you manipulate the x values is you have to go after, the variable inside of what's considered the function. So if I have f of x minus c, this is a shift right c units. If I have f of x plus c, this is a shift left c units. Now it messes with students because you kind of think that subtraction should be going in the negative direction and adding should be going in the positive direction. But remember, when you're working with x, algebraically, you have to solve for x. So if I was trying to isolate x by itself, assume I do the inverse and get rid of f, but your last thing that you would have is an x minus c. In order to isolate x, you would have to add c. That's why you're actually moving, in the positive direction, c units. And similar here, your last step would be x. You'd have to subtract c to solve for x. So that's why you would move this left. Now, the verticals move the way you'd expect them. So if I take my y values, because remember y is equal to f of x, so this was the original y values. If I take my y values and add something, I'm going to move it up. And if I take my y values and subtract something, I'm going to move it down. Now, your compressions, what if you want to squish and you want to stretch horizontally? Well, again, your horizontal moves are manipulations on the x's. That's why this is f of c times x. And remember, x's move opposite of what you think. So if c is a proper fraction, so between 0 and 1, you're actually stretching it. And if c is a bigger than 1, you're actually compressing it. So for instance, if I have like f of 3 times x, that's technically a compression because remember, in order to solve that for 3, I would have to divide all the x's by 3. So that's why this is a compression. As opposed to something like if I have 1/4 x or x divided by 4, what I have to do is I'd have to multiply by 4, and that's why that would be a stretch. Okay, now the y values move the way you'd expect them to do as well because you evaluate y as opposed to solving for x. So when c is a proper fraction between 0 and 1, it's going to be a compression, and when it's bigger than 1, it's a stretch because you're taking the y values and you're multiplying them by a number. Now, reflections are going to be multiplying everything by -1. So multiplying this by -1 is going to flip over the x-axis. My bad. Is going to flip over the y-axis. Remember that you're manipulating the x's, so it's kind of like a horizontal move. So if I multiply the x's by -1, I'm going to take this x and I'm going to send it over to the other side. So what it's going to do is it's going to flip it over the y-axis because that would be a horizontal move. As opposed to, multiplying the y values by -1, it's going to take a y value and it's going to send it below the x-axis. So that's why it's a flip over the x-axis. So again, think of a video game like these things are your stretches. So if you're zooming in, this is how you would do this. Now, if you need to zoom in both in the x and the y, you'd have to, do it in both spots at the same time. Now, if you're looking at water in a video game, you can see the water is a direct reflection of the rest of the world. So that's how, you could do the water if you're flipping over the x-axis that way. All right, so let's set up some examples and put this to work. All right, so what I want to use for this example is I want to use the parent function f of x is equal to x squared in order to graph these things. And what I can see is that these are manipulations on the squaring function. So for the first one, I want to do x minus 3 squared. And what I notice is that I am manipulating, the variable inside of the power. Remember that the power is our function. So really I could write this as this is the same thing as the square function being our f function. So our f function is our squaring function. So our squaring function, I could write this as f of x minus 3. So what I know that is taking this particular function and moving it right 3. So what I know is that the x squared function looks like this. And what I'm going to do is I'm going to take that function and I'm going to move it right 3. So taking that function that started here, I'm going to move it right 3, and now it's going to look like this. Now that's why we call this a rigid transformation again, because its shape has not changed at all. All I'm doing is taking it and moving it right 3. Now for this one, we can see that this is y is equal to, remember that our squaring function is now here. I can write this as f of just x minus 1. So I can say I'm just subtracting 1 to all the y values. So this is, a rigid transformation that shifts everything down 1. So now we have something that looks like this. The original function just down 1. Again, it's a rigid transformation. It has not changed its shape. Now this is a non-rigid transformation. I'm actually going to stretch it, and I'm going to try my darndest to make it look like a stretch. Notice that your squaring function is still here. So what we have is we have y is equal to 4 times f of x. And what I know is that it's just multiplying all the y values by 4, so taking my original function and multiplying them all by 4. So, remember, this is the point 1, 1. What's going to happen here is that's now going to become 1, 4. You're going to multiply all the y's by 4. So now this is going to go up 4. Now you have 2, and then when you square that, you're going to get 4. So now your 2, when I multiply, 2 would have spit out 4, but now I'm going to multiply it by 4. So this is going to be way up to 16. So you can see that this thing really is going to be looking very skinny, but it's not technically skinny, it's actually stretched vertically. And then finally, let's kind of put everything together. So if I want to graph this, I'm going to do them in kind of order. I want to see what happens here, and what I'd like to do is I'd like to handle the x-coordinates first and then the y-coordinates second. So what I can see is that this x minus 3 is going to be, right 3 units. That takes care of all the x values. So that's, that's your x values. Now your y values, what's going to be manipulated here is going to be this 4 and this 1. Now, the way you handle x values is you have to solve for x, and since it's only one operation, I'm just going to move it right 1. But the way you handle the y values is you have to evaluate for y. So if I have, this is really 4 f of x minus 1. So if I was going to stuff something in that particular spot, if I was going to evaluate it, you can see that I have to multiply by 4 first and then add 1 second. So that's why I have to do that vertical stretch first. And then I have to go down 1 second. So let's see the progression of these, and I'll write this out. So first, if I want to go my parent function, let's just start it over here. We got a lot of room. So to D, let's do our solution, and I'll just do moving this way. So our parent function, this is y is equal to x squared, looks like this. Now I'm going to move it to the right 3. 1, 2, 3. So now it's going to look like this. Now that is, I shouldn't change its height because I don't want to make it look like I'm stretching it all. So that is y is equal to x minus 3 squared, which we had before. Now I'm going to vertically stretch it by 4. So 1, 2, 3, this thing. So what I have is now this is going to be 4 times x minus 3. So I'm going to vertically stretch this one. So it's still over here, but now it's going to look, well, it really should go up 4 times for instruction. I'm really trying to stretch it by a factor of 4. And then finally I have to take this thing and I have to go down 1. Boom, boom, and this is going to go down 1. So now you can see that this right here is finally my solution. Y is equal to 4 times x minus 1 squared. X minus 3 squared minus 1. All right, let's do another function. We tend to always start out with x squared. Let's try a radical function. Then we'll also talk about the solution points and make sure that they work. So what I mean by that is, for instance, let's just look at this before I move on to the radical. It'd be nice to see two things. So what I know is this thing has a solution point. This thing right here has a solution point 2, 4. Wow. Let's just 2, 4. So where does that one move? Because what I can kind of tell is that this thing's vertex is going to be 0, 0. We can see that the vertex is going to spit out, 1, -1. And if you, sorry, that should have been 3. Let me make that work. 2, 3. I'll get a little lazy here. So this is actually going to be equal to 3, -1. So we can see that if you guys know something about the vertex, that the vertex is 3, -1. And that's really why, because of transformations. So let's see what happens to that point 2, 4. Well, this thing took it right 3. So if I start at 2, 4 and make it right 3, I'm going to have to turn that 2 and turn it into a 5. So, adding 3. So this is going to be 5, 4. And then I need to multiply this by all the y's by 4. So 4 times 4 is going to be 16. So way up here is going to be the point 5, 16. What I did is I just multiplied all the y's by 4. That one right there. And then finally I have to pull this thing down 1. So moving it down 1 is going to turn that 16 into a 15. So this is 5, 15. Now, this one was true. I know that when I plug in 2, I indeed get 4. So that is a solution to 4. Now, my claim is that 5, 15 is going to be a solution to this because that 2, 4 moved to 5, 15. Let's check it. So when this should be 15 when I plug in 4. So when I plug in 5 minus 3 squared minus 1. So this is going to be equal to 4 times 2 squared, which is going to be 4. So this will be 4 times 4 minus 1, which is indeed 15. All right. So let's do this with a function that's not a square. Let's try a root. All right, so what I want to use is this function f of x, which is equal to the square root of x, which is this known parent function here, to be able to graph this new function. And what I can see is that our new function is of the form, remember that my f function in this case now is my square rooting function. So f is this root function. So I can see that, this is going to be my root function, so I can rewrite this as, minus 3 times f of x minus 2 plus 1 minus 4. Now, it's technically needed to see that, but then you can put it back into the definitions that I wrote in the beginning of this. All right, so let's talk about the x values, let's talk about the y values, and then we'll do the progression of curves to be able to finally graph this. So let's start out with the x coordinates. Well, if I want to do the x coordinates, we're going to have to look at, what manipulates, I'm going to say x values. So the x values. So what manipulates x? Well, what manipulates x is going to be the thing inside of the function. So it's going to be this piece right here. Now remember that you have to solve this for x. So if I want to solve this for x, I know I'm going to have to subtract 1 and then multiply by 2. So we're going to have to, subtract 1, which really means that this is going to move, left 1. So this is left 1. And then I'm going to have to multiply the thing by 2, which means it's going to be a vertical stretch of by 2. Now for your y coordinates, the y values, we know that these are done through manipulations on the y, which are going to be, this minus 3 and this minus 4. Now remember what we have is we have something of this form. This is y is equal to minus 3 f minus 4. And I'm not worried about the inside because, these are going to be the manipulations on the y coordinates. I've already done the x coordinates. So if I was to plug something, in the f location, say if I was going to plug in, I don't know, say 4. Well, what I'd have to do first is I have to do the multiplication first and then the subtraction second. So x's you solve. You'll have to do outside to inside, so subtract, multiply. Now, the y values are evaluation, so I'm going to have to do the multiplication before the subtraction. Now, this multiplication, this negative sign, really is a, this is a multiply by -1, which really represents a, you know, a flip or a reflection. So remember, this is a y move, so it's going to be a reflect about the x-axis. Now I'm also going to have to multiply this by 3, which is going to be a vertical stretch, you know, by 3. And then finally I have to go subtract 4, which means I'm going to go down 4. All right, so let's do the work. So we're going to start out with that parent function. We have y is equal to the square root of x, so y is equal to root x is going to look like the half of a sleeping parabola, so something like this. And now what I know I have to do is, first we're going to have to subtract 1, which means this is going to go left 1. So left 1, we have this function, rigid transformation. So this is y is equal to the square root of x minus 1. Sorry, x. Subtract 1, I have to, which is going to be x plus 1. Because I have to solve for x. Now we have to divide all the x's by 2, so which means I'm going to have to multiply this by 2. So now we're going to have this. So vertical, nice. Horizontal stretch. Remember, these are x values, so this is a horizontal stretch. So I'm going to stretch this thing horizontally, which means I'm going to stretch this value as well. Right now this is going to be -1, so now when I stretch everything, this is going to be -2, and it's going to look like this. But everything is going to stretch by 2. So now this is going to be y is equal to the square root of 2x plus 1. Oh, my bad. X over 2 plus 1. Now I have to reflect over the x-axis. So taking that and reflecting it over the x-axis for these y values, it's going to look like this. So now this is y is equal to minus the square root of x over 2 plus 1. And then I'm going to have to multiply everything by 3. All the y's, I mean. So this is going to stretch this thing by 3 vertically. I'll try my best. So now this is y is equal to minus 3 square root of x divided by 2 plus 1. And then last, I'm going to have to subtract 4, which means move this thing down 4. So finally, our solution right here is going to be here. And I have to go down 4 to this spot. So now we're going to get that function. So finally, this is y is equal to minus 3 square root of x divided by 2 plus 1 minus 4. Okay, so that was our goal to be able to graph this. Now I want to do a little bit more just to see what happens here and kind of verify that this actually did work. And let's start out with, that's kind of like a vertex. So this is the point 0, 0. And let's see what happened to that point. Well, this now is going to be 0, 0, and now this is going to be equal to -1, 0. And if I plug in -1, well, this would be the square root of 0, which will give me 0 back. So this is a solution of this. Now over here, this is going to be the point -2, 0. So if I plug in -2, this is going to be -2 divided by 2, which would be -1, plus 1, which would be equal to 0. The square root of 0 is going to be 0. So when I plug in -2, this will indeed be 0. Similar, if I plug in -2, this would be the square root of still 0. So -0 is still 0, so I'm still going to get the point -2, 0 for that. And then similarly here, multiplying, this is still going to be 0, so multiplying by 3 is not going to change it. The more interesting point is, let's make sure that this one works. Well, this is the point -2, -4. So if I plug in -2, let's just make sure that that works. So this is going to be minus 3 square root of -2 over 2 plus 1 minus 4. I need to make sure that this spits out, this coordinate, so this should be y is equal to that. So simplifying, this is still going to be equal to 0, and -3 times 0 is 0. So this is going to be, -4 is equal to -4. All right, now that was a pretty easy one because we went through 0, 0. A more interesting one would be, how about, say, I know the square root of 9, 2, 3, 4, 5, 6, 7, 8, 9. 9 is going to spit out 3. So I know that this is going to have the point 9 comma 3 because the square root of 9 is equal to 3. And let's see what happens to that point. Well, I know I'm going to have to go left 1. So moving left 1 is going to take that 9 and turn it into an 8 comma 3. Remember, I'm going to subtract 1 to all the x's. And then I'm going to multiply all the x's by 2. So now that 8 is going to be over here. This is going to be 16 comma 3. Now we can work on the y values. When I multiply it by negative 1, it's going to flip it over the x-axis. So it's going to be down over here, which is minus 16 comma 3. I have to multiply the y's by 3. So now it's going to strip that. I didn't do that right. That was wrong. This is 16 comma negative 3. Remember, I'm handling the y coordinate, so it's going to flip it over the x-axis. Now I have to multiply the y's by 3, so I should have made this a little bit bigger, but this is going to now be the point 16 comma minus 9. Remember, stretching the thing by 3. And then finally, I have to go down 4 to these y values, so minus 9 minus 4 is going to be minus 13. So finally, that point is going to be 16 comma minus 13. And let's just check to see if it is a solution. And we'll do it over here because I have ran out of room. So let's do it in this tiny little spot. My apologies for squishing it all in. So what I need to make sure is that, this indeed is a solution of, this equation here. So if I plug in y is equal to 16, this is minus 3 times the square root of, what is that? That makes, this is, I'll get it right, I promise. So this is minus 13, which is the y coordinate. And this is going to be minus 3 times x, which is going to be 16 over 2 plus 1 minus 4. So we're just making sure that when I plug in x, I get that particular y coordinates. So let's check it out. So minus 13 is equal to negative 3. The square root of 16 over 2 is going to be 8, plus 1, which will be 9 in the radical, minus 4. So now minus 13 is going to be minus 3 times the principal root of 9 is going to be 3 minus 4. So this is minus 9 minus 4, which is actually equal to minus 13. So if you like the content, please consider liking, subscribing, and sharing.